Hey guys, how you all doing out there? So in this video we'll be looking to estimate the mean and standard deviation from a bell curve using some really cool properties about the normal distribution. Okay, and this question 13a came straight from the June 2013 Edexcel GCSE statistic paper. Okay, so without further ado, let's jump in. So here's the problem, and what does it state? Well, this says that some students did 2 mathematics tests. The students' marks for the test are normally distributed. The diagram shows the distribution of marks for test 1 and test 2. Okay, so as you can see, we've got 2 bell curves, and in this particular example we're going to focus on estimating the mean and standard deviation of the marks for test 1. Okay, so ignoring test 2, let's just focus on the middle one, the first one. Okay, so let's estimate the mean. So what do we know about the bell curve? Well, we know it's symmetrical across the mean, so that's saying that bang in the center is where the mean lies. Okay, so if you look closely at the top of the graph, we can see that the center lies around there, about 55. Okay, so this is just an observational question. Okay, so now how about we estimate the standard deviation? Okay, so what do we know about the standard deviation? Well, let's have a look at this graph and information here. So we should notice that the region encompassing the first quadrant, we say that the region covering approximately 68%, so adding up the 234% is roughly 1 standard deviation away from mu. Okay, so this tells you the distance, and in terms of standard deviations, it tends to go up to +3 standard deviation, plus minus 3 on either side. So carrying on, we can also say that if we encompass up to this mark, where we have 13.6 plus the 234 plus the 13.6, we have roughly 95%, and this is almost 2 standard deviations away from the center of mu. So again, here we can write mu minus plus minus 2 sigma and so on. And lastly, and this is where things get really cool, we look at the third point, which is this, when we sum up all of it, including the 2.1, 13, 34, and you do the other side too, and this should roughly encompass 99.7%, and this is 3 standard deviations away from mu. And if you think about 99.7 is pretty much the whole area, it's practically everything. Okay, so what we can do here now is of course replace mu with 55, and now the other 2 values at the end. We should never work with plus minus sigma or 2 sigma. We should obviously work with the whole area, the plus minus 3 sigma, because if you look back at the graph, considering the entire graph, an entire bell curve, the minimum point is 25 over here, you see, and the maximum point is 85. And of course, this is, if you're going to shade the entire region, this would be nearly 100%, or in this case 99.7. so it's safe to assume that at the end we should have 25 and the other end should have 85. So here, as you see, 25 should be there and 85 should be there, and this should be equivalent to the mu plus minus 3 standard deviations. So hence we can just solve this algebraically. Okay, so let's work on the right hand side for a second. Let's back to the right. So using the right hand side, we should have this, so 85 here should equal the 55 plus 3 standard deviations. Here we are, and this is the case of solving algebraically. So subtracting 55 and dividing by 3, then boom, sigma equals 10, and that's it guys, that's your standard deviation. But alternatively, we can look at the left hand side where 25 is. So instead of using plus 3 sigma, we have negative 3 sigma. So we're going to have 25 equals 55 minus 3 sigma. Once again, subtracting 55 and dividing by minus 3, we should again yield sigma equals 10. So that's it. This is how you do it. So to know, we should always look at the whole area at the minimum maximum point at plus minus 3 sigma, and just equate it to the value. So this is dead easy. It's always good to look at the whole area. I don't think it's smart to look at 60% of the area, because we don't know where the hell that really lies, and we can't just guesstimate it. I mean, if you look at my graph, it looks like it'll be 45 and 65 because it's divided in 3s. But again, I think it's best we just stick with the endpoints. Okay, anyway, hope this helps. Leave a comment, and if you've got any other problems, suggest to me, give me a quick private message. I'm here, I'm here full time. But have a good day, guys. Chill out, and good luck with any other problems. And so Adios.